First of all, thank you for taking out time to watch this video. Today we are going to discuss the CAP theorem. CAP theorem is basically related to consistency, availability, and partition tolerance. So, what do we what do you mean by consistency? Consistency means everyone sees the same data. So, in today's distributed system, there are multiple nodes which are serving the request, which are storing the data. Okay. Now, suppose when I request from node A, then it should return the same data when I request from node B. So it should be same in node A and node B. So that is consistency. And what is availability? Whenever I request, I should always get a response. That is the availability part. And what is partition tolerance? In the distributed networks, there are nodes which are interconnected, but then there could be some network failures. Like if you could say node A is not connected to node B because of network failure. That is called as partition tolerance. Now, what the CAP theorem says. So network partition is a must. Okay. So during a network partition, like node A and node B, there is a network issue. Okay. So during that kind of partition or failure, so what do we choose? How do we go about it? Either you go with consistency or either you go with availability. That depends on your use case. But you cannot have both consistency and availability at the same time. We'll understand this with an example. Now say the first one, CP. So what we are saying is, I will provide only correct data. Correct data means all the nodes have the same data. Node A, node B, node C, node D, whatever. They all have same set of data. Even though request fails. So if request fails, we are compromising on availability. That's the point. That is why here A is missing. So during a network partition, my goal is to give consistent data. If I'm going with consistency, then I'll have to forego availability. That is why request fail. Now in term, if we go to AP, I want my system to be highly available, always available. In that case, I'll have to forego consistency. Why? Because I'll have to respond. But because node and node B are disconnected because of network partition. So there is a case where data may be stale. So take an example here. Node A and node B, a network partition occurs. Node A, user updated on node A. Okay. But since there was a partition, the update never went to node B. Now this update is missing in node B. Now some other user sends a request and it goes to node B. It gives what? Stale data. So here you have compromise with consistency as you wanted to make sure the system is highly available. So that's the point. And why can't we have all three? This is the example. So node A, node B. Okay, user updates on node A. Another user reads from node B. It gets stale data. Now here there are two options. Okay, in this case, you return old data. So here you have going with availability, but you have compromised consistency. So this is AP, available and partition. Now second is, I want to give the same data which is there in node A, but I'm not sure because there is a network partition if the updates have reached to me, if there was any update. So in that case, I'll refuse to respond until the unless communication is restored. So in that case, I'm giving priority to consistency. So here I'll be refusing the request. If I refuse the request, here I'm making it the system less available. So availability is compromised. So this is consistency partition. Okay. So during a partition, we can either choose consistency or availability. We cannot have both. Okay. And very common question is CAP saying we can only choose two of three? So not exactly. You could say in the presence of network partition, that is the communication failure. You must choose either between consistency and availability. That's what CAP is saying. Okay. And since partition tolerance is something which is mandatory in distributed system, so the real choice is CP or AP. You cannot have everything. That's the point. And now these are some of the real examples, real world examples. In banking, consistency is very critical. So I'll go with consistency and partition tolerance. I can compromise on availability, but I cannot compromise on data. Similarly, payment gateway. Data is very important, so consistency cannot be compromised here. In case of DNS, my goal is it should be highly available. I can compromise on consistency. That is why it is AP. In case of social media also, I can compromise on consistency. That is why, and I want to make sure system is always available. That is AP. Similarly, product catalog. And in case of configuration service, it will be CP. Reason being, configuration has to be same, has to be consistent. Okay? And that is why I compromise on availability. Now, leader election. So when leader election means there is a quorum. So in that case also, consistency is important. So these are the examples, and this is what CAP theorem says. Hopefully, this video will help you understand the CAP theorem. Thank you so much. Have a good day.